Today we're talking about the trigonometric inverses and their graphs. Right now what I'd like you to do is I'd like you guys to go ahead and graph y equals the tangent of 2x. Just go to our graphing calculator right now. Go to the window button. You'll notice if you look at our graph, this right here is the x minimum. This is the x maximum. The x scale is going to be at pi over 4 because it's perfectly between a 0 and a pi over 2. So I'm going to go ahead and mark this right here. This is at pi over 4. This is 2 pi over 4, which makes this 3 pi over 4. This is at negative pi over 4. And this is at negative 3 pi over 4. So go ahead and put these numbers right here in your graphic calculator. Go ahead and do that with me now. We're going to go from negative pi to positive pi. Our x scale is going to be pi divided by 4. I believe we're going from a negative 2 to negative 3. Okay, so negative 3 to a positive 3, but the y scale is 1. Okay, the y scale is 1. You're going to hit y equals. You're going to type in the tangent of 2x. The tangent of 2x. Okay. So when you type in the tangent of 2x, you're going to hit graph. And you're going to take a look at this graph. So this right here is the tangent of 2x. So what you're going to do is you need to draw in some asymptotes right here on your paper. These are vertical asymptotes. So make nice sketches to provide you the boundaries for your graph. And also, make sure you plot your zeros right here on the x-axis. So where are all your zeros located? They are located right here at 0 pi, at pi over 2, and at pi. Over here at negative pi over 2, and at negative pi. So you're taking this graph and you're transferring it over to your paper. So the very first thing that I would do if I were you is I would go ahead and draw in all my asymptotes. So get those nice drawn in. And then right here at negative pi over 2, 0, pi over 2, and pi, that's where your tangent of 2x graphs are going to go through. Look at your graph, your calculator, and just transfer what you see. Now, we've already graphed tangent of x and tangent of, we've graphed these before, okay? But one thing we have not graphed is the inverse of this function. So we're going to talk about what an inverse will look like. My apologies. Thank you, Angela. I forgot. There we go. Is that better now? All better. Now, I want you guys to understand, whenever you are graphing inverses, okay, the key thing you want to make sure you understand is inverses and their functions always reflect across y equals x. Inverses and their functions always reflect across y equals x. So here's what I want you to do. Go to the calculator. Hit y equals. Go down to here to y3, type in x, and hit graph. So my inverse should reflect across this graph y equals x. Now there's kind of a cool thing that you could do in your graphing calculator, that the calculator will actually draw the inverse. They won't tell you what the function is, but it'll draw it for you. Okay? So check this out. What I want you to do is I'm going to go to second program where it says draw. I'm going to go to number 8 where it says draw inverse. So if you're wondering how I got that again, I'll do it one more time. You hit the second button, you go to where it says program, which you have the word draw is in blue, and you go to number 8. Now, I want to draw the inverse of my y1, the function that's in y1. So to get to that, you have to hit alpha and then the trace button. If you hit alpha trace, those two keystrokes, that will take you to the screen. So I'm going to find the inverse of y1, and then I'm going to press enter.
Oh, so it just like turns it sideways,
Right now, what's the calculator doing for me? It's drawing the inverse. Can everybody see? It kind of almost looks like a net, doesn't it?
Yeah.
All right? It's kind of freaky. It reminds you of All right? All right? But does everybody see how these are reflections across this line right here? Okay? So right now, I'm going to hit y equals. All right? I'm going to go down here. I'm just going to hit x again. Okay? So this is what we have. So I cleared off all those inverses. So this is what we have so far. So what we're going to do now is we're going to teach you how to solve for the inverse. Like, how do I find the inverse of this function? Like, what's the actual equation? So what I want you guys to do is go down here, and in your journal, I want you guys to start by writing y equals the tangent of 2x, or y equals the tangent of 2x. Now, in your journal, make sure you understand you are going to be doing something called finding the inverse, all right? Finding the inverse. Now, most of you have done finding an inverse before. Maybe you just haven't done finding an inverse with the tangent of 2x, okay? But the very first thing that you would have to do when you find this inverse, all you have to do is step 1, switch or exchange the x and the y values. Exchange x and y. Exchange x and y. So instead of y equals the tangent of 2x, I'm going to write x equals the tangent of 2y. Alright, so that's the first step. Exchange the x and the y. Alright, step 2. Now, you need to solve for y. And when you solve for y, you have found that function's inverse. So right now, to solve for y, right now, what's y being multiplied to? It's being multiplied to a 2, and then it's being multiplied to this concept called the tangent. So this is what you guys need to do. You need, in order to get rid of this tangent, you have to take this side right here and multiply that tangent by its inverse. So I'm going to put tangent right here in parentheses times the tangent of 2y. And whatever I do on one side, I have to do on the other side. So right now, what's going to happen? The inverse of tangent times tangent, they literally cancel to 1. Any number and its inverse, when you multiply together, equals 1. So they cancel out. And what you're left with is a 2y on this side, and over on this side, you're left with the inverse of tangent of x. So I'm going to rewrite it right here. 2y equals the inverse of tangent of x. Now, before you guys solve for y, I'm going to rewrite it as arctan. This is another way that you will see it. If you see arctangent of x, that's talking about the inverse of tangent. These mean the exact same thing. So I want you to understand, this is what it looks. This is what you're going to use in the graphing calculator. Okay? What that means, if you see this in a textbook, or you're reading a problem, and it says arctangent, that's what it's talking about. Now, a lot of you are like, well, what are we going to do? We're going to divide both sides by 2. But instead of thinking of dividing both sides by 2, what I'd like you to do is multiply both sides by a half. So this half cancels out this 2. And y equals 1/2 the arctangent, or the inverse of tangent, of x. This is your inverse. This is the function that is the inverse of our original function. So if you wanted to, in your graphing calculator, this is what you are going to use in your graphing calculator. So this function right here is what we're going to type in right now. Okay? So right now, go to your graphing calculator, go to y equals, okay? Right here at y2, I want you to type in 1 divided by 2 second tangent of x. It only comes with 1. Yeah, it's not gonna. It's only going to graph one of these. Okay, there are certain things that are going to be restricted that the graphing calculator does. So you're going to see one of them. Okay, you're not going to see all of them. But can you guys see how this red curve is the inverse of this one right here? Mm-hmm. And by the way, what's on this one? This is at a what? A pi over 4. This is at a pi over 4. But can you guys see that this red one and this blue one are indeed inverses? Okay? They're perfect reflections across y equals x. So that right there is what you're going to graph, everybody. You're going to graph this one right down here. So let me show you what I want you guys to do to graph it. We're going to change. We're going from -3 to +3. Our y maximum has changed to a pi over 2, and our minimum has changed to a negative pi over 2. So here's what I want you to do to help you guys graph this right here. I'm going to go to window. I'm going to change my window from a -3 to a +3. My x scale is going to be a 1. My y minimum is going to be negative pi divided by 2. My y maximum is going to be a positive pi divided by 2, and my y scale is going to be pi over 4. So I'm changing all of my window settings. Okay? So I'm going to go ahead and take a little picture of this so you guys know that this is at negative pi over 2, this is at positive pi over 2, this is at pi over 4, this is at -3, 3, and a 1. Okay? So right now, I'm going to go to y equals, I'm going to take everything out except for this one graph that I want you to graph on your paper. So everything's cleared out now. Hit graph. So what I'd like you to do is I would like you guys to understand that this graph is going between right here, a positive pi over 4, and a negative pi over 4. It's going right through here. This is at a 1. This is at a 2. This is at a 3. This is at -1, -2, -3. Take this graph and transfer it over to your assignment. Just remember, this graph is 1/2 the inverse, or the arctangent, of x. All right, now, everybody, this right here is y equals pi over 2, the arc cosine of x. Now, by the way, you guys see this capital A? That capital A means something. So, go to your notes. Go to your notes. See here. Oh, it says, capital letters are used to distinguish the function with restricted domains from the usual trigonometric functions. Okay? So, if you see a capital letter, what's been restricted? The domain. So watch this. Check this out. Look over here. This is very, very, very important. for all of you right now, check this out. If you see a capital S or a capital A, capital C, the domains and the ranges are restricted except for tangent. Arctangent, the domain is not restricted. And for regular capital T tangent, the range is not restricted. But everything else has restrictions. So what are we dealing with? We're dealing with what? Arc cosine, right? So right now, you guys see those? On your paper, can you write that restricted domain and that restricted range right there, please? From here to here? You got it? Take a picture. Right? I'm going to go.
Write it on number 2.
Yeah. So right now we're going to go right here. I'm going to say, you know what? Let's go and write this down. What's my domain have to be between? All of my x values have to be less than or equal to 1 and greater than or equal to a negative 1. Okay? And my range for this problem, all right, has to be between what? What do my y values have to be between? Whoops. Pi and 0. All right? Pi and 0. So right here we go to the range and say you can get all the way up to a pi, but greater than a 0. Now, if it's shifted up pi over 2, then it's automatically going to go a little bit higher. So we're going to add another pi over 2. So the highest that this one would get would actually, let's add something, ready? Our range for this function, since it was shifted up pi over 2, is going to be 3 pi over 2. And we're going from 0, where's it going to finish out? It's actually going to finish out at pi over 2. So right now, this right here, your graph has actually been shifted up a little bit, okay? It's been shifted up pi over 2. So here's what I want you to do. We're going to make this graph, all right, in your graphing calculator. Go to Window, plus you. We're going to go from -1 to +1. And the x scale is 1. We're going y minimum, go to 0, and the y maximum, 3 pi over 2? 3 pi divided by 2, and the y scale is at pi divided by 2. So I'll take a quick little screenshot of this so you guys know what we got. This right here is at 3 pi over 2. This is at pi over 2, in case you're wondering what to type in. So now I get y equals. I'm going to clear this out. I'm going to start with pi. Y scale is pi over 2. Half a pi plus second cosine x. Half a pi plus second cosine. Just remember, this is the same as saying arc cosine. And then hit graph. Take a look at it. It literally stops right there. Remember, what did I say the domain was going to be? What are my x values between? A 1 and a -1. What is this graph between? It's between here at a -1, here to a +1. What did I say the range was going to be? It was going to be less than or equal to 3 pi over 2, but greater than or equal to pi over 2. Now normally, normally the regular graph would end here and it would start here. So if you're wondering, typically, what happened to this graph? It was shifted up, right? So watch what happens when I hit second cosine of x. You'll see this other one will just drop down. Watch. So this one wasn't shifted up pi over 2 units. That's why this one's a little bit higher. So yes, I do want you to go ahead and graph to the best of your ability this graph right here on your paper. Okay. Now how do you take that graph and put it on your paper? Right here at -1, I want you to go right up here where it's at 3 pi over 2, and I want you to put a point. Right over here at +1, I want you to go over here where it says pi over 2, and I want you to put a point. Where does it go through? That point goes through pi, but don't make it just a line that connects it, because it's not a line, it's a curve if you look carefully. See it? So you're going to kind of drop it down a little bit. It's going to curve through this point. Finish off there. This right here is the correct graph of this inverse of cosine function. The next thing we're going to do is we're going to show you how to take this function and find its inverse. So we're going to graph it and you'll see how they are inverses of each other.
This is arc cosine.
The next one's going to be cosine. The next graph will be cosine of something. Okay? So, everybody, this is your, okay, check it out. See your graph right here? Remember when I colored it in yesterday? This is what we wanted to focus on, was right here. That's what we just graphed, right here. Okay, so now we are going to find the inverse of this. So we started with this. Y equals pi over 2 plus the arc cosine of x. So here's what I want you guys to do. We are going to find its inverse. So the very first thing, what are we going to exchange? X and y. So the x equals pi over 2 plus, now I'm going to change it right now to the inverse of cosine, and I'm going to put y. So exchange the x and the y. That's the first step. All right, step 1. We have to isolate this. All right, the best way to isolate this inverse of cosine is to take away a pi over 2 and take away a pi over 2. That zeroes this out. On the left-hand side, what you're left with is this. You're left with x minus pi over 2 equals the cosine of negative 1 times y, which is the inverse of cosine. Now, the last problem, what did we do? We multiplied both sides by the inverse of tangent to get rid of tangent. This time, to get rid of the inverse of cosine, we're actually going to multiply both sides by cosine. So we're going to multiply the right side by cosine. And we're going to multiply the left side by cosine. So what happens? These cancel to a 1. And you're left with the cosine of x minus pi over 2 equals y. So I'm going to write y equals the cosine of x minus pi over 2. This is the inverse that you're going to take and you're going to graph. All right, so right now what I'm going to do is I'm going to go to our window right here. I'm going to hit window. I'm going to change my x minimum to 0, my x maximum to 2 pi, my x scale to pi divided by 2. The y minimum, I'm going to go to negative 1, the y maximum, positive 1, and my y scale 1. And at y equals, I'm going to type in the cosine of x minus pi divided by 2. And I'm going to hit graph. And a lot of you looked at that and said, wait a second, that looks just like a sine of the x graph. Well, you know what? The sine of x is actually equal to the cosine of x minus pi over 2. If I wanted to write another one, I could probably say, I wonder what the cosine of x. That one actually ends up becoming the negative sine of x graph on that one. I'll have to shift more. Okay? So these graphs are the same. So right now, what do I want you guys to do on your paper? I want you guys to go ahead, draw a line here, draw a line right here, start right here, go through pi, finish at 2 pi, go all the way up, right here, and down, and back up. Now leave that in your graphing calculator because what I want you to do is we're going to type in both of them so that you can see that they are indeed inverses of each other. Okay? So leave this right here. Go down, we're going to type the original one, which was pi divided by 2 plus second cosine of x. Over here, I'm going to hit x. Now, one of these, this guy's restricted. Remember, this was restricted. This one's not. So when I hit zoom 4, type zoom 4, this does not have any restrictions, but this does. So you see how this graph, it just stops. But if you wanted to check to see if you actually found the correct inverse, if you're like, I'm not sure if that's correct or not, here's what you need to do. I'll clear this out. Second program, number 8, alpha trace number 1. And you can see the inverse. If the domain and the range weren't restricted.
That's what I was going to say. So technically, if it wasn't restricted, it would just keep going
right.
That one.
Exactly.
Since it's restricted, it just only stays between the negative 1 and 1.
And that's the hard part to see. It's like, well, how do I know? So that's why I wanted you to understand if you use that draw inverse, if it wasn't restricted, it would continue going.
Kind of like when we colored the little things into
right.
writing, it would be like
when we colored them
that's
in.
the little colored part.
Yeah. So understand, the only thing that was actually allowed to be plotted on this one was from where? It was basically from right here to right there. So all you could see was what? You could only see from there to there. Okay? But those are indeed, we did find the inverses. So here's what I need everybody to do. What I'm about to show you is going to be very important from 3 all the way through 8. I need you guys to draw some right triangles that are going to be very, very special and very important to remember their properties. There are only 2 special right triangles that you need to be aware of. One of them is the 30, 60, 90. And the other is the 45, 45, 90. The properties of the 30, 60, 90. I'm going to write x. I'm going to write x radical 3 and 2x. Here I'm going to write x, x, x radical 2. We'll make a little table for you. 30, 60, 90. X, x radical 3, 2x, and I'm going to plug in some numbers that you typically will use in a 30, 60, 90, like 1, 1 radical 3, and a 2. You'll notice in some of these problems, you'll notice it has a radical 3, or it has a 2, or it has the number 1. That means you're dealing with what? A 30, 60, 90 triangle that you're going to be working with, okay? Over here in the 45, 45, 90. Right now we're getting ready for the next day. We're not going to use this today, but you need to make sure you are aware that this is what we're going to be utilizing when we work through problems 3 through 8. 1, 1, 1 radical 2. You need to look at your unit circle that you all should have in your journal, your unit circle that goes all the way around and it has pi over 6, pi over 4, pi over 3. You should have it in your journal. You're going to be using that to help you with finding all of these values. Okay? So make sure you have this down and then you can have a wonderful day.